Okay, now we can begin to talk about lesson 9, the spatial curve movement. For the first part is 1.4.1, that is the spatial curve. The spatial curve of a particle. First, we can think about the snowflakes in winter. They are like moving in the wind. Their projection is either a linear line nor is a plane curve, but it was more complex, so it can be a spatial curve. There are multiple factors that can influence how the object moves, but most objects are doing spatial curve movement. To describe how a particle moves in the space, we can set up a reference. In this reference coordinate, x, y, and z, we have an object moving, suppose like that. So it can write as RT. At time t, its position was RT, and at time t plus delta t, its position was RT plus delta t. So, like during this time, it experienced a movement of delta r. The vector r can be decomposed into 3 components: the x component, y component, and z component. Thus, we can write r equals x I plus yj plus zk, where ijk simplifies the unit vector in the x, y, and z direction. So, thus we can write r equals rt is the same as x equals xt, y equals yt, and z equals zt. So, the delta r, that movement between the displacement between t and delta t, is equal to rt plus delta t minus rt. And thus, the infinite small movement delta dr can thus be decomposed as dxi plus dyj plus dzk. The same way, our velocity v equals dr dt can thus be decomposed as vxi plus vyj plus vzk, where vx equals dx dt, vy equals dy dt, and vz equals dz dt. This is exactly you differentiate the r term, and thus you get v. And our speed v is the square root vx squared plus vy squared plus vz squared. It is exactly as the plane curve movement. We can do the same as the acceleration a. Acceleration a is defined as dv dt equals d squared r dt squared, and thus can write as axi plus ayj plus azk. We differentiate the velocity vector v again, we can get ax equals dvx dt equals d squared x dt squared, ay equals dvy dt equals d squared y dt squared, az equals dvz dt equals d squared z dt squared. Also, like the spatial curve movement of a particle can be set in the spherical coordinate or like other polar coordinate as well, and we do not discuss here.